Okay, so the World Bank collects information on life expectancy of a person in each country and the fertility rate per woman in their country. The data for 24 randomly selected countries through 2011. So we've got the fertility rate, we've got the life expectancy. We're going to test at the 1% level for a negative correlation between fertility rate and life expectancy. So we're going to go stat, test. Well, let's graph it first. So list 5 and list 6. So there's our pretty strong negative correlation, and there's our regression line right there. And remember, we do that by going stat, calc, linreg, and then store it in vars, yvars function y1. All right, so very strong negative correlation, very high r-squared value, so 86.7% of the variation in life expectancy is explained by the regression line. And okay, so now we're going to do the test. So we're going to go stat, test, linreg t-test. And again, list 5 and list 6, we're checking for a negative correlation, and we're going to calculate it. So there is our t-score for our slope. T-score is gigantic, almost negative 12. The probability of that happening by random chance is next to 0. So therefore, we have very strong evidence that, that we have a negative correlation, and it's not just occurring by random chance. There's the standard deviation of our errors around the line. So for part B, the standard error of the estimate is 3.2. And now it says compute a 99% prediction interval for the life expectancy. All right, so we're going to have to, life expectancy of a country that has a fertility rate of 2.7. So we need to plug in our 2.7. So we're going to go second calc a value when x equals 2.7. So we've got 72.17. So when x equals 2.7, not x bar, but x, our y value, or our predicted y value, is 72.17. Okay, so now we need to build our prediction interval for this. So we're going to go 72.17 plus or minus our margin of error. Remember, our margin of error formula for this is going to be our t-score times the standard error of the estimate times this correction factor, which is 1 plus 1 over n plus x naught minus x bar squared divided by the sum of the squares of the x's. Okay, so we're going to have to fill in all these blanks here. So our t value, right? So it's a 99% confidence interval. So it's 99%. But which one do we use? Well, we've got 22 degrees of freedom because sample size was 24 different data points, right? So we've got a t-score of 2.819. So this is 2.819. Our s value was, I believe, 3.2, right? Let's see, stat, test, linreg t-test. And 3.2035, 3.2035, and then times the square root of 1 plus 1 over 24 plus, now this x naught, that's our x value, which was 2.7, minus the average x. Well, we got to find that, so that's stat calc 1 var stats on list 5. That's our x values. So our average x was 3.0208. 3.0208 squared, divided by the sum of the squares of the x's. And so right there's the sum of the squares of the x's, 285.71. Okay, so we gotta type in all of that stuff, right? So we're gonna go quit out of here. 1 plus 1 over 24 plus, and then this is going to be 2.7 minus 3.0208, 3.0208 squared divided by 285.71, and then we're going to take the square root of that, and that's 1.02079. So now I've got 2.819 times 3.2035 0.035 times 1.020797. So let's take all of those and multiply them together. So take that number times 3.2035 times 2.819 is 9.22. And that's our margin of error. So we've got 72.17 plus or minus that 9.22. So that's anywhere from what, 72 plus 9, 81, 81.4 roughly, and then subtract 9 from that, right? So we can go like this. We can go 72.17 minus that, 62.95, and then 72.17 plus that, and that gets me up to 81.388. So we're 99% confident that the true fertility rate, that the true life expectancy is somewhere between 62.95 years and 81.388 years, with 99% confidence for a country that has a fertility rate of 2.7.